The Clatsop County coast of Oregon, February 1942. A little after 7 in the morning, in rain that had been falling for most of a week. A faller stands on a springboard, driven into the flared butt of a Sitka spruce, roughly 8 feet above the ground, his partner braced on a second board on the far side of the trunk. Between them runs a falling saw over 8 feet long. He is a documented type rather than a documented name. The men who cut coastal spruce in these years appear in company records mostly as a payroll number and a district. But the working moment is documented closely, in Forest Service wartime reports, in mill receiving records, and in the oral histories later collected from loggers who worked the Oregon and Washington coast between 1941 and 1945. What he is deciding is not whether the tree comes down, it is where it lands. The slope below him falls away toward a creek bottom studded with the stumps and windfall of an earlier pass. Somewhere under the salal on that hillside there is rock. He cannot see it. He can read where it likely is from the way the ground breaks and from what came off this same face last month. And this tree is not ordinary timber. It has been marked for aircraft stock. That single fact changes everything about the next 20 minutes, because the value of this spruce does not survive impact the way a fir sawlog does. A fir that breaks across a hidden ledge still becomes a beam. A spruce that breaks may become nothing at all. So what exactly made a tree aircraft grade in 1942? And why did that specification reach all the way down to a man standing on a plank in the rain? Aircraft grade meant clear, straight-grained, and defect-free. Sitka spruce earned its place in aviation for a narrow set of physical reasons. Its strength-to-weight ratio was exceptional, the property that had made it useful for aircraft frames and propellers in the First World War, and for masts and ladders besides. Its long, tough fibers did not splinter readily when struck by a bullet, and it grew, in the coastal fog belt from Northern California through Oregon, Washington, British Columbia, and Alaska, to sizes that yielded long, unbroken lengths of wood without a knot in them. The specification was not new. In 1917, the Allies asked the United States for 100 million board feet of Sitka spruce and were explicit that ordinary spruce would not serve. The Army built the Spruce Production Division to answer that demand, nearly 30,000 soldiers by Armistice Day, headquartered at Vancouver Barracks, 19 camps in Oregon alone. The output figures vary by source. The Oregon Encyclopedia records 53 money 718,591 board feet of aircraft-grade lumber, contributed by soldiers against total production of 8,961. The National Park Service history credits the Vancouver plant alone with 109 million board feet of aircraft-grade lumber between February and November 1918. Both figures are large. Neither is small enough to explain the difficulty. The difficulty is this: from any given spruce, only a fraction of the wood met the grade. Everything else went to boxes, crating, barracks, dunnage. So the faller on that springboard in 1942 was not cutting a log. He was protecting a percentage, a portion of clear wood inside the trunk that a bad landing could erase in about 4 seconds. What then actually happened to that wood when a tree came down wrong? Before we continue, if this kind of documentation is what you've been looking for, consider subscribing. Every video on this channel goes into one specific element of American logging between 1900 and 1980, what the falling crew, the rigging crew, the steam donkey, the logging railroad, or the river drive actually required, what the men running them had to know, and what the wood they cut actually became once it reached the mill. Not folklore about giant lumberjacks. The documented technical reality of a dangerous trade practiced by skilled men under real physical risk. What a faller's judgment gave a wartime crew that strength alone never could. A log that reached the landing whole and straight-grained, still worth something to an aircraft plant 3,000 miles away. And if someone in your family worked in the woods in this era, put it in the comments. If someone in your family cut timber between 1941 and 1945, what did they say about the year the power saw first showed up in their camp, and what did the old fallers say about it? Next on this channel, the Alaska Spruce Project of 1942, and the crews the Forest Service sent north to reach aircraft-grade timber that no logging outfit had ever touched. Back to the woods. A large coastal spruce carries an enormous amount of stored energy on the way down, and the ground receives all of it in an instant. Where the ground is deep duff and brush, the trunk beds into it and the fiber survives. Where the ground has a buried ledge, a windfall, or an old stump beneath the moss, the trunk lands across that point and the load concentrates. The result is documented plainly in period logging photography and in mill records. A long split running the length of the butt, or a clean break with shattered fiber fanning out at the ends. For a fir saw log, that is a loss of some volume. For aircraft stock, it can be a total loss of grade, because the requirement was defect-free wood in long clear lengths, and a shake, or a split running through the best part of the butt, disqualifies exactly the section the aircraft plant wanted. This is the specific reason the faller's read of the hillside mattered more in 1942 than it had in 1938. The war did not change the physics. It changed the price of getting the physics wrong, and the read itself was not a formula. It was an accumulation, where the rock came near the surface on this face, which draws held soft ground. How this species behaved when it was leaning across a slope rather than with it. How a spruce butt that looked sound from the outside sometimes was not. None of that was in a company manual, and there is no evidence any company tried to write it down. It was carried in the heads of men who had cut this ground before, which raises a question the war made urgent. How many of those men were still there? Before that, the tool, the two-man falling saw known throughout the woods as the misery whip, had been the standard felling technology of American logging since the 1880s, and it remained standard until gasoline chainsaws became practical in the 1940s. In Pacific Northwest old growth, the blades ran long, and sawmakers such as Simons and Atkins had developed heavier blades and specialized tooth patterns specifically for Douglas fir and coastal timber. A crosscut saw does not cut by force, it cuts by geometry. The cutting teeth sever the fiber, the raker teeth clear the severed material out of the kerf. If the relationship between those two is wrong by a small margin, the saw stops removing wood and starts riding in its own dust, and two strong men can work for an hour and accomplish very little. Which is why the most consequential man in many camps was not in the woods at all. He was the filer, in a shack with a vise and a bench, working through saws in rotation with files, gauges and setting hammers, keeping tooth height and raker depth within tolerances he judged by eye and by feel for the timber being cut that week. A falling crew's output was substantially a function of the filer's judgment. In wartime, when camps were being pushed for volume, that quiet bench job became a production bottleneck nobody outside the industry ever heard about. So the war's demand landed on two kinds of accumulated skill at once. The faller who could read ground he could not see, and the filer who could tune a saw for wood he never touched. Both were skills that took years. And by 1942, years of experience had become the scarcest material in the American woods. Who was actually left cutting timber? The wartime lumber industry faced a straightforward contradiction. It was asked for record output at the exact moment its workforce was being drawn into the armed forces and into higher-paying shipyard and aircraft work on the coast. The government's answer was blunt. Labor shortages were severe enough that loggers were exempted from the draft. Cutting timber was treated as war work because the war ran on wood, hangars, barracks, ships, truck decking, aircraft, bridging, and above all crating and boxing for every item shipped to Europe and the Pacific. The workforce that filled the gap was not the workforce of 1939. Older men who had left the woods came back. Men well past the age at which fallers usually stopped falling stayed on the saw. Inexperienced hires arrived in numbers, and camps that had once been able to pair a new man with a veteran for a season now had fewer veterans to spare. Women entered the industry in significant numbers, in the mills and in the woods, the Pacific Northwest counterpart to Britain's Women's Timber Corps, over 6,000 strong between 1942 and 1946, known there as lumberjills. And the labor shortage redrew the map. African-American loggers and sawmill workers from Louisiana, Mississippi, and East Texas moved to timber regions that were hiring, among them James W. Williams, who went from Mississippi to Flagstaff, Arizona, and recalled making more in a single day there than he had made in 2 weeks in the Mississippi woods. This was a workforce assembled at speed to meet a quota, and the quota itself had by then acquired the force of law. What did it actually mean, administratively, when lumber was declared a war material? It meant that the government took control of where the wood went. In May 1942, the War Production Board issued Limitation Order L-121, establishing partial control of mill lumber sales and deliveries. This was not unprecedented. The War Industries Board had issued a comparable control order on mill sales in October 1918. In October 1942, the WPB went further and ordered a halt to all non-essential civilian construction. Price ceilings on lumber, logs, and stumpage followed, with the Forest Service's experiment stations consulted on their effects. The Forest Service also launched the Timber Production War Project, aimed at raising lagging output while, notably, encouraging methods that left trees standing for future use and wasted as little as possible. Alongside it ran a large-scale logging program in Alaska, specifically for urgently needed aircraft spruce, and the routine manning of forest lookouts as part of the Army's aircraft warning system. Whether the shortage was real remains genuinely disputed. War agencies emphasized a national gap between production and consumption. In January 1943, Wilson Compton of American Forest Products Industries argued publicly that the 6 to 7 billion foot gap meant increased imports and reduced inventories rather than unmet war needs, and that all war and essential civilian demand had in fact been met. Compton spoke for the industry, which had an obvious interest in that conclusion. Both positions are on the record. The evidence does not clearly settle it. The regional figures show strain either way. Western pine production in the first quarter of 1943 ran about 827 million board feet, below the records of 1941 and 1942, above any first quarter before 1940, while shipments of 1,168 million feet drew regional stocks down to 851 million. But cutting the tree was never the hard part. Getting it out was. What did that require? Coastal spruce grew where the ground was worst, steep, wet, broken, and often a long way from anything that could carry a log. The answer since the 1880s had been steam. The donkey engine, a boiler and winch mounted on a heavy timber sled, dragged logs from stump to landing on wire rope. By the 1910s and 1920s, this had developed into high lead yarding. A selected tree was climbed, limbed, topped and rigged with blocks and guy lines to serve as the central mast of a cable system, so that the leading end of the log lifted clear of the ground instead of plowing through everything in its path. The high climber who rigged that spar held the most exposed and generally the best paid job in the camp. The consequences of that work are documented in company safety records and in oral histories. The methods are not the subject here, and were never something a manual could confer. From the landing, the wood went out by rail. Geared locomotives, shays and climaxes, built to hold traction on grades and curves that would have defeated a conventional engine, worked temporary track laid on timber trestles across coastal canyons. Where trestles were impractical, tugs towed boomed rafts down the rivers and estuaries to the mills of the lower Columbia. Every part of that chain was built for one purpose: to move very large logs out of terrain that did not want to give them up. And during exactly these years, that chain was quietly being replaced. What was replacing it, and why did the war accelerate the change? Heavy-duty log trucks had been developed through the 1930s. The war put them to work at scale, and by 1960 they had displaced most logging railroads in the region. The reason was flexibility. A logging railroad was a capital commitment to a specific piece of ground: survey, grade, trestles, ties, rail, water tanks, a section crew to maintain it. It made sense when an operation intended to work one drainage for a decade. It made no sense at all when the demand was for particular timber, aircraft-grade spruce, in stands scattered along the coast, needed immediately, in whatever quantity could be reached before the end of the quarter. Trucks in a bulldozed road could reach a stand in weeks, and the tractor that cut the road became, itself, a second machine in the woods. The same substitution ran through the yarding side. Steam donkeys gave way to gasoline and diesel yarders during and after the war. The new machines started faster, needed no firemen, and did not require a cordwood supply hauled in behind them. None of this was invented by the war. All of it was accelerated by the war, because wartime demand rewarded speed of access over efficiency of investment, and because the industrial capacity to build engines had expanded enormously. That expansion had one further consequence, and it arrived at the stump. For the first time, The thing being replaced was not the railroad or the donkey engine. It was the falling saw itself, and with it, the two-man crew that had defined the trade for 60 years. Where did that machine come from? It came from Germany, and at first it did not work very well. Chainsaws appeared in Oregon forests in the late 1930s. In 1939, Weyerhaeuser bought 3 steel machines from a seller in Germany and gave Jack Jameson the job of finding out how to run them and whether they were practical at all. One of them weighed 145 pounds and carried a guide bar roughly 6 feet long. That is the honest beginning of mechanized felling in the Pacific Northwest. A man in a Washington logging camp, wrestling a machine heavier than he was, trying to determine whether it was a tool or a novelty. The early saws ran what was called a scratcher chain, which had to be sharpened and resharpened through the working day. In practice, they did not cut appreciably better than a well-filed two-man crosscut in the hands of a good crew. Most loggers regarded them as a waste of time, and on the evidence they had, they were right. What changed the calculation was the war. Weight and maintenance had limited adoption. Lighter models still required 2 men to operate. But as camps were pushed for volume with a thinner and less experienced workforce, more loggers and more companies took up power saws specifically to meet war demand. The machine did not win on merit in 1942. It won on arithmetic, because a crew that could not be assembled from experienced fallers could sometimes be assembled from 1 experienced man and 1 machine. And after the war, the arithmetic changed again. In a Portland shop of about 800 square feet, Joe Cox worked on the problem the scratcher chain had never solved and produced the chipper chain, a chain that held an edge and cut properly. Manufacturing capacity built for the war made saws cheaper and easier to produce. Within a few years of VJ Day, one-man chainsaws were on sale at retailers. Paul Skirvin, who founded an Oregon logging company and whose working life ran from the post-war expansion into the timber wars of the 1990s, bought his first power saw from Montgomery Ward. It weighed about 60 pounds. By his own account, it let him and his brother work 5 to 10 times faster, and the wartime demand that had driven all of it was immediately eclipsed by what came next, the post-war housing boom and the second great cutting of the Northwest. If this channel is going to keep documenting what it actually took to log an American forest by hand and by steam, subscribe. There are more falling crews, more spar trees, more steam donkeys, more logging railroads, and more river drives that quietly built the houses, the towns, and the railroads of a growing country, and were never described as historically significant at the time because the men doing the work didn't have time to think of it that way. What that judgment gave a wartime crew was never strength. It was a log that arrived at the landing hole. And if you have a connection, a relative who worked as a faller, a high climber, a donkey engineer, a riverman, a log truck driver, put it in the comments. If someone in your family was in the woods between 1941 and 1945, what did they say about the year the power saw arrived? Still to come on this channel, the Alaska Spruce Project of 1942 and the crews sent north for timber no outfit had ever cut. The coastal faller's work, in its original two-man form, ended in the years immediately after 1945. By 1950, the one-man gasoline chainsaw had changed how the work was done. What the chainsaw gave the trade, speed by a factor of 5 to 10, an end to the physical exhaustion of the misery whip, and eventually a job that one man could do without waiting for a partner. What it did not give anyone, the reed of a hillside that could not be seen, the knowledge of where the rock lay under the sallow, built out of seasons of watching what happened to logs that landed there. He did not know this was what the years in the woods had built in him. He knew it the day a new man dropped a clear spruce across a buried ledge, and the mill downgraded it to crating. The saw had known what to ask of him. No one had thought to tell the machine to ask.